Hi! You probably know that for the last 5 years I have been writing an operating system with a community of enthusiasts. Lately a friend of mine started contributing to the project, and among other things, he wrote a simple graphical interface for the OS. This is very cumbersome to do in C, so we considered switching to another language. For reasons I will get into later, we felt like none of the major lower level languages really suited us. So we decided to write our own programming language, trying to steal the best features of several programming languages we like, avoiding their worst features. We will first show an excerpt from our presentation of the language, and then showcase the features by actually showing you some code. Here are some timestamps, so you can jump to the live coding bit if you're not interested in the presentation.
Welcome them with an applause. Okay, I was about to kill myself. So, who are we? This friend of mine is Alessandro Scala. He's a PhD student at the University of Edinburgh. And this is myself.
This is himself, Lorenzo. He's a master student here at the University of Pisa. He's the host of the Daedalus community, which, for you following at home, you should know what it is.
This is us, and you, some of you. The Knights Who Say Lambda. What's Knights Who Say Lambda? It's a group of students who organize some seminars about many things, among which science, mainly computer science, to be honest, philosophy. There was one seminar about the reproduction of lizards, and 2 seminars, if you believe that, about the decline of frogs, which is also related to the reproduction of frogs. Well, the more you know. Okay. Okay, so MellOS. MellOS is a minimal, collaboratively written kernel conceived by myself in 2020, originally targeting this beast right here, the 1984 Compaq Presario. What's the goal of the project? Well, originally it was just to learn how to make an operating system for myself. At some point it became a learning tool for people who want to learn how to make an operating system.
Or how to not make it.
Or how to not make it, yeah. Because
hopefully to make it not.
Yeah. And so it's a learning platform, essentially, for how to make an operating system. Its current features are a simple file system, a memory allocator, some drivers, a command line interface, and like very simple program execution. I tried to make a workshop about the operating system, which nobody came to. But yeah, okay.
That's actually how I got into.
Yes, that was useful.
So yes, that had a point.
Yeah. It would appear that not a lot of people want to be locked in a room for 4 hours.
4 hours,
writing. Yeah, but he is one of them. But he was in Edinburgh, so yeah.
I was locked in my room.
Yes.
My own room.
Yeah. Okay, so when Alessandro joined the project, he did a bunch of things for the operating system. He improved the memory layout of the kernel. He wrote a floppy disk driver, wrote a VESA driver, and
I started working on the graphical interface of the OS. Mainly, I started by writing a kind of basic GPU driver. But most importantly, after making the driver for the GPU, well, let's say that of course I wanted to use this driver, and I wanted to write a graphical interface for it. Now, you can write a graphical interface in C perfectly fine, yes, of course, but if you want to make a GUI toolkit, something you can, for example, create a window, and from this window react to callbacks like keyboard input, mouse input, and everything else. You would need to have some kind of callbacks or handlers for these events, and you can do them in C, of course. But the easiest way would be to sort of implement your own classes by hand, make a struct containing the data for a window, and have some global functions like window underscore init, and pass the pointer to the structure. It's not pretty. So, but that's how it currently works. But then I was talking with Lorenzo, and we thought, okay, we have a programming language, an operating system. We want to do something with this operating system. we want to do it more in a way that's more comfortable, and doing it with C is just ugly and time-consuming. So, what are possible solutions? We're writing it in C. We could change the language. Of course, remember that we're in a very low-level setting. So, what language could we choose? C++. It has definitely good features. It has classes, which could be useful for our Windows system. Concepts, which are like traits, type classes, if you know about those. So it could be useful. And lambdas, which are, of course, we love them. But, well, C++, yes, has a lot of features. Has too many features. It's a really bloated language. And someone doesn't like C++ syntax. I personally don't mind it, but it's a bit of a mess. It also needs runtime support if you create objects. It's not the best idea. So what else could we do? We could change the language to Rust. Yes, it has a lot of good things, good features. Again, traits, which are like concepts, lambdas, which we love. Memory safety, really useful. Options, really good way to program safely. But it's just a pain in the ass to work with. I hate Rust syntax. I'm not alone in this.
Yes.
We love the theoretical framework, the background, but we need to write bare metal programs. Rust is. We think it's not the best option for this. So, what did we decide? We thought, why don't we write our own language? The idea behind this language is we borrow. No pun intended with Rust borrows. Anyway, we borrow some ideas from good, popular languages, but we keep these features low level enough that it can work really with no friction together with C, and that we can, in order for us to write low level programs, but in the most modern and more convenient way possible.
Yes.
So that's the concept behind the language.
Now, before we get to the features, I need to do a thing. I need to check whether we are actually live, because I will showcase the features. So let's begin with a C snippet. What we'll see in this presentation is only the currently implemented features, so no future stuff for now. Okay. Let's begin with a C snippet. First off, some syntax. We write it in a more modern way. But it's still bad, isn't it? We don't just want to change the syntax of C. We want to do something more. So, what's missing in C? Some type inference, for example. It's not there. It's not like very advanced. It's very basic type inference.
Yeah, but it's good.
But it's good enough. Yeah, and we're trying to make it better. There is a few changes that I didn't tell you about.
I'm worried.
Yeah, I'll tell you later. Okay. Yes. So this then option types, because of course there is a big problem with C and many other languages, which is null. Null is a problem, and we don't want null pointers. There's many reasons why null is bad, and it's basically the cause of most errors in programming. And so what we did we copied option types from OCaml and
Kotlin syntax.
Yeah, Kotlin syntax, which I don't know Kotlin, but yeah, I suppose
It's very good.
yeah. And so what are options? Options are basically a wrapper of a type, and it's a box outside of a type. Yes, and the box can either be empty, which is nothing. So if the box is empty, there's nothing in the box. And if the box is full, there is just the thing inside the box. So in OCaml, this is some and none.
Which are names that I like more than... Or actually, I like something and nothing.
Yeah.
Not just.
Yes, the thing is, since we disagree a lot about these things...
We have multiple ways of writing.
Yes, Perk currently accepts... Yes, currently we can write none in place of nothing, some in place of just, and we can mix up the thing. So yeah, when it comes to the first release, we will choose one.
We will converge on one.
Yes.
We will choose one of them from your one and the other.
We might
We
do
have
that.
2 forks.
Yes, we might do that. So then we have lambdas, as I was saying.
The most painful feature to
Yes, so
program in this language.
initially we did lambdas in like an afternoon, but they were not capturing.
And we realized that only later when we tested them.
Yes, so to make them capturing, it was a bit of a pain. And later we will see, when we actually look at the compiled version of some code we've written, we will see how it's compiled.
Works, yes.
And but okay, so the language has a static subset which does not use the heap. So we use, essentially we use non-capturing lambdas in that subset, and we use capturing lambdas in the whole language. I hope you like the syntax. If you don't, tell us and we'll probably change it.
And the reason why we have this static subset is basically, okay, we tried making lambdas work on the heap, on the stack, but we tried in many ways, it didn't work. It didn't work out. So we ended up deciding to put lambdas on the heap, right, for the environment. Well, now, since we want to use Perk to program OS's kernels, we would like to have a programming language that doesn't use the heap, so that you're expected to do memory allocations on your own, on bare metal programs. So the compromise was that, yes, you can do this, but you cannot use some of the features. And if you want to use them for other kinds of programs, like the game that we made, you can do that. But you will use the heap, which is fine for that.
Lambdas, okay. Type classes. Okay, type classes, you may know them as traits or concepts. They're the same thing. Of course, everyone calls them different things, so we went for archetypes and models. So an archetype is a type class, and a model is
the
implementation. Yeah, so it's both the struct, what you would call in Rust the struct, and the impl. So yeah.
And if you come from Java, because it's the best language ever, you can think of archetypes more as interfaces in some way, and models as classes implementing those interfaces.
So this is an example of an archetype. It's it's an interface. There's not much to say. What can we see from these from this thing? Yeah, okay. We have tuples, which we do not have in C.
Yeah.
Yeah,
they're really useful. Why don't we have them in C natively?
Yes, models. Again, this is a class essentially. So yeah, a model can implement one or more archetypes, and zero or more archetypes. Yeah, you're correct. And of course, the thing is, if a model implements an archetype, you've got to implement all the members of the archetype. Yeah, and that's pretty much. Of course, we have constructors. Mm-hmm. Do you want to talk about those? What's there to say? Do you not know what a constructor is?
Everybody knows what a constructor is.
I'm sure you all know. I can see the chat. How do you use models?
Of course, since we have very sensible keywords and so. Well, when you have a model, you summon it to make a new one, and then once you're done with it, you have to banish it, right?
Which makes sense.
Makes sense.
Yes.
Yeah, these are of course new and delete in C++.
Yeah. Okay. So how do you actually use archetypes? Want to talk about that?
Yes, of course, you can use them. Basically, like, yes, a constraint generic type for
Myself. Yeah. We.
And the way you okay, for now, if you want to pass an argument, a model as argument to one of these functions that take a archetype sum as parameter, for now you have to manually cast it. How do you cast it? What's the keyword?
As.
You can use as. You can use an arrow, a
squiggly
squiggly arrow.
Yes.
But it didn't look good on the presentation, so we used as here.
Yes.
This is an explicit cast. We have type inference. We can do an implicit cast later. It's just not implemented yet.
Then, of course, we have, since what we do is we translate this to C, essentially. So we have a way to embed, like inline C.
And because the idea is that maybe you don't want to write the entire kernel in this language.
Yeah.
Especially if you, like us, already have a code base and we couldn't be bothered translating it immediately. We will at some point, but not now. So we want to have compatibility with C, like at a source level.
Yeah. And also, like right now, if you want to do some like very dirty stuff, you cannot quite do it in Perk. There's a few things that don't work.
It's too safe.
It's safer than, but it's not as safe as say Rust, but it's safe.
It's not. Of course, it's not safe as Rust.
Okay. Well, it's the funky time of the presentation.
Okay, so we totally did not forget to share the screen. And we are not recording several days later.
Definitely not.
Okay. So I think we were about to show our game.
I think so too.
Okay.
Well, yes, this is the game that we are making as a sort of benchmark for our language. So here you can see an example on how you can use Perk. Of course, we will start our program with all the imports that we need. And as you can see, these are actual C libraries. Now, for now, the plan is to have a full import feature that makes it easy to work with C libraries. But for now, you can import the libraries, but the symbols defined in the libraries are not imported by the type checker doesn't import those symbols. So we still need to define them. But this is a temporary measure. We will make it work seamlessly with C libraries. So as you can see, we are defining a few symbols that we need that are defined in the SDL library. And then we define a few colors with our beautiful tuples and a few other library variables that we need for our game. Then we have a few math functions, and this will be eventually moved into a separate library. But for now, again, our library import doesn't really work as you'd expect yet. But it's of course, it's a feature that we will have. Then we have a couple of, well, don't worry about these models here.
Yeah, don't worry about those.
They're just a dirty hack that we were using that is not necessary anymore, but it's still there. But again, it's not necessary. And then we define a few models, and here we have our SDL model. Now we decided to basically wrap the SDL library functions into a model. So this way you don't have to call all the various functions like you do in C. So basically have SDL underscore create window, and then you pass an object of type SDL. We didn't want to do this, so we decided to wrap this into a model, and so that you can use it natively in Perk.
Yep. And the way we do this is by using the begin C and end C.
Yes, basically we
instructions.
have inline C just a regular perk function that wraps some inline C code. That's the gist of it.
Yeah. And one thing to notice is that, well, we have syntax highlighting and we have actually a working LSP.
Yes. Yes.
Which we totally made ourselves and not by using ChatGPT.
Yeah, no, because we really wanted to learn how to do VS Code extensions, right? It's such an interesting topic. So
yeah, we're keen to learn.
Anyway, after our SDL model, we defined a few archetypes, and these archetypes, well, this one is for objects, let's say, that need to be drawn on screen. And to draw something on the screen, you just need a position, rotation, a texture, so you have to know what to draw, and a size parameter to scale it. Then we have a physics object, which also has position and rotation, but you will also need some other variables to compute physics properties or physics interactions, let's say. And then an actor model archetype, to basically force objects that need to act. For have your main character, and you want it to move according to your inputs, you can do that. Or if you have an enemy that moves towards you, then you will also do that inside this function.
Mm-hmm. Yeah.
Then we have our model, Perkio, which is our main character, which of course implements all three archetypes. And one thing to notice is that for example, the position and the rotation of an object, of a model, if you define them into multiple archetypes, well, there's only gonna be one variable for the position, one for the rotation, and they're basically shared between archetypes. So they don't implement multiple variables with the same name, which would be rather confusing.
Yes.
Yeah. So this is the implementation for it. It implements a draw function and an act function and so on. And this is the enemy, basically, which is also implements the three archetypes. Then we implemented the list, which is it's gonna be a list
fully generic.
It's not yet fully generic. Yeah. For now, it's a list of drawable plus physics object plus actor, so it can hold models that implement these three archetypes, which are gonna be Perkio and the enemy. And of course, since Perk is a functional language, kinda.
Indeed.
We have a for each function in our list that takes a lambda and applies it to all the elements in the list. Then we have a physics manager to control the physics, to move the objects according to gravity and all of that. A camera to render everything in our game. A game controller to glue everything together, basically.
Mm-hmm. And then the main function.
And the main function, which does SDL stuff, initializes it, creates the window, all of that, instantiates the object, and starts the main loop and polls for input. Don't worry about this.
Mm-hmm. Yeah, no, this is very weird, but it's temporary. Okay.
Yes. It's a temporary measure
just because we couldn't be bothered. Yeah.
Yes, because since we don't have yet full compatibility with C types, the easiest way to write this loop is to just drop into C and write these things in C instead of defining models to mirror these variables. Again, this is something that eventually will not be needed because we will have native support for
Yeah, but it's good to be able to do this kind of stuff.
Yes. And yes, that's basically it. Then you just draw the window and update everything each frame. And
then you banish
you can
everything.
see. And then you banish all the models. Oh no, what have I done? Okay.
Okay.
I think now we can show you how the game works.
Yeah, definitely. Let's show them.
Yes. And yes, run. And this is our beautiful
Yay!
game.
As you
Isn't
can
it
see,
the
the
best
enemy
game
does not do much. It only bounces.
Isn't this the best game you've ever seen? So this is the generated C file, starting from this. Actually, I think we can do this.
Wow.
Some libraries are imported automatically because they're needed for the, I wouldn't say runtime, but for some things in the language, for how some stuff is implemented. Then
And
you
for
have,
some reason, you work backwards.
yeah, I just realized that. And I know
Yeah.
why, because we are pushing them on a list, and then yeah, all right,
Okay,
that's gonna be fixed soon.
Yeah, that's a bug. Okay.
Yeah. Okay, then we have a lambda, and basically this is a capture, right? So it's a struct that contains a pointer to an environment and to a function, and this is how we implement lambdas.
Mhm.
And
It's a dummy closure bit.
It's a dummy closure, yes. And then we have a function to allocate this, to allocate a generic lambda. And some macros to call those lambdas. Actually, maybe it's better if I do this. Basically, we assign the lambda to the lambdummy and then call the function inside the struct. And the reason why we do that is because we want to pass the environment, and we need to have a reference to it in order to be able to access it. So it's not the prettiest thing, but it's alright. Then we have a few type definitions for our function types and for option types. And as you can see, option types are just compiled as a struct, where one field tells you if there's something in it, and the other field is just the contents.
Mm-hmm.
Then we have how models are compiled, but we're gonna see a better model than this. Some other function types.
The function types are very funny.
Are very yes, they're very readable. I mean, can you
Yes,
tell
indeed.
whether an SDL texture putter rect float top float int to void r is? It's
Yeah, I mean,
it's very readable.
well, we made it. You know it, but
And I argue that it's way more readable than C style function types.
yeah, and the most important thing is these types are not meant to be seen by the
Exactly, they're not meant to
by
be
the user of
read by the user. They're just
Yeah, they're internal representations
Mhm.
essentially.
yes. Now,
Although
here-
they sometimes for now leak into the type checker. So if you write something
into
of the
error
wrong type,
messages.
it will sometimes show that you would have needed something of type alrect tup float le tup float le void etc. Yeah. So
yeah.
we'll see.
Yeah. I mean, it's readable. Yes.
Yeah.
Anyway, this is how we compile archetypes. And basically, you have a pointer for each field of the archetype. So if we go here into the drawable, right?
Yeah.
We have a position, rotation, texture, and size. And position, rotation, texture, size. And these are pointers so that you can reference the real fields instead of having duplicates for inside models. There's another archetype here and a third here. And now this is how we compile models. Oops. And models are just structs, of course, and there's a field for each field of the model, and then a struct for each archetype it implements. So for example, if Perkio implements struct drawable, there's a drawable struct inside the Perkio struct, which has pointers to the variables, to the fields here. And you will be able to see that in the function that initializes models, which is a bit further down below. Then we have declarations for our lambdas. There are a lot of lambdas in this program. These are the tuples that we defined and all the other variables, functions, and these are initializer functions. I wanted to see, yes, this one. Now this is the function that initializes, that creates a Perkio model. So first of all, they're allocated on the heap. Then you initialize all the fields and the functions. No, not these ones, but yes, for example, this is a function that needs to be initialized with the values that you defined in the model definition. Oops. In the model definition. And then each archetype needs to be initialized as well. So we put a reference to the actual field into the field of the struct of the archetype. And then you call the constructor and return it.
Okay, so
You want to show? I'm gonna follow
Metaperk,
you.
as I said, in the context of the video, I have made this interpreter this morning. Although that morning has long gone now.
Yeah.
But I have not touched it since, so I have not changed any of it. It's still made in the morning. Okay, so it's not very good as a consequence. As before, we have a few imports and we have a few externs for the reason Alessandro talked about earlier. I will first show what the language actually looks like, what the language I'm interpreting actually looks like. And now it's the time that I should do some actual live coding to show what they look like essentially. Okay, so the program is written in Polish notation. So, for example, if I write the number 5 and I go execute, it should be. Okay, I can use the terminal. Good. Yeah, run Metaperk. Okay. So you can see that the program tokens are 0 and 5. 0 is the end of the program, and 5 is the number at the input, and the result is 5. If I do +5 1, and I repeat the compilation, and I save the program, of course, the tokens are end, number, and plus. And essentially, so I do plus of the two numbers, and it's 6, and then I finish the program. And I can do more complex stuff. I have effects, so I can do, say, print 6, and we will have that
a program printed 6 and then returned 0. And I have concatenations of commands. So I can do print 6 and then print 7. Okay.
Concatenation in
Yeah.
Polish notation is so great.
Yeah, it's good. As I said, the language is not great because otherwise I couldn't be able to write.
It is great.
Perkio anymore. Yeah. It's ironically great. Okay, we have choose. We can choose between based on whether equals 3 and 4. We can choose between 5 and 6. So what this will do is if 3 is equal to 4, then it will output 5. Otherwise, it will output 6. And of course, we are expecting that it says 6. And yeah, it did. And if I put a 3 here, it should say 5. Okay. The language is Turing complete. So we also have while. We also have for, but
Yeah.
for is a bit boring. We have while. We can say, for example, so before showing while, I will show how to do store and load. Okay, so I can load 0, 3. Okay, so what this does is it loads into, in quotes, memory location 0, the number 3. What do I mean by memory location 0? Essentially, here we have a memory, which is an array of length 2, 5, 6, and yeah, and this is the memory of our program. So it's actually not Turing complete. Yeah, but no language is Turing complete. So okay.
Well, if you create an array of infinite size, then it's Turing complete.
Yeah. So it's if you take the limit of the length of the array, then it becomes Turing. I can do store 0 to 3, which will store the number 3 into location 0, and then I can do load 0, and these should return 3. No, it didn't.
This shouldn't be, yeah.
Because I did this. Okay. Okay. Yeah, it did return 3. And then I can do, for example, while I think I have this for inequality. While it's different, so while load 0 is different than 0, we can decrease the store. So we can store 0 minus load 0 1. Does this look good to you?
Yes.
Okay. And but we do not actually have any effects, so I might want to do something like this. Print load 0.
Right. Yeah.
And what this does is it goes down from 3, prints 3 to 1. Okay.
Good.
And now essentially we're ready to run the big boy, which is the Fibonacci program, which essentially what it does is it prints the Fibonacci sequence up to a certain point. So I think it prints it up to the first Fibonacci number that is bigger than 100 because of this check. Then how does this work? So we have token stack. The token stack is essentially a list with 2 special functions that are push and pop. They're done in the worst way possible, in the linear time way. But I couldn't be bothered to do it any other way because I was in a hurry. So yeah, I did this way. A token stack, so it's a list of tokens. What's a token? It's a tuple. The first element of which is it's a string representing what kind of token we have, and the second one is it's a number that is either 0 if the token does not have any value, for example, if it's an operator or if it's AND, and it's the number. So it's if it's number, then the second value is the number itself of course, we use option types on the next. An element of the list contains a value, which is a token, and then it may contain a next element.
Mm-hmm.
And we have a constructor that sets the value, push and pop, okay. And then we have, of course, a very basic stack operation, which is the function that copies the stack. Of course, every stack has this operation, as we all know. Yeah, this is needed essentially for a purpose that I will show later.
Well, yeah, because this stack is not immutable; it's mutable.
Yes, because we're not in a camel, and I might say thankfully, but not necessarily. Okay. Then we have a print function. Yeah, it does what it says it does. Then we have this, which pretends to be a camel. It's a failed with message. Few other functions. This one's my favorite. This is the curried string equality function. So it's a function that takes a string and it returns a function that checks whether the input string of that function is equal to the string that was the input of the string equality, the curried string equality function, which is a very bad way of saying that you can do stuff like this. So you can define EQ, which is the curried string equality function of S, which is the string you want to lex, and then you can check whether it's equal to any of these without writing S a bunch of times.
And this is the kind of thing that we want to do with this language. Because yes, you can do currying in C, but please don't do it. Having a language that has this kind of things natively is way more convenient.
Yeah, definitely. Then we have the way we parse integers is by using the French function atois. And we have a few other functions, and okay, we have the tokenized string. I will not go into the details because tokenizing is the worst thing that you can do, and so we have a bit of a non-feature here. So we currently cannot, in some cases, we cannot return a token stack. In general, we cannot return a model type, because these are voidized essentially in some points of the code because of dependency issues. But then again, I think Alessio, which is a member of the Knights Who Say Lambda, he told us that we need not do this. We need not have dependency. So
because you can forward declare types, so we could have broken the circular dependencies in another way.
Yeah, and then it's the actually important bit is so this skip computation part and this execute computation. Okay, I will start from the execute computation and then I'll get to the skip computation. So, what the execute computation does is it takes a stack as an input, and it checks whether the first element, so it pops from the stack and it checks whether the element it's popped is a number. If it's a number, it just returns that number. If it's an operation, it will execute the computation. If it's a binary operation, it will execute the computation twice. First on the input stack, and then on the stack that is the result of the previous computation. And then what you do is you return the stack, and you return the sum if it's a plus. Return the sum of the two numbers that are the result of the computations.
Mm-hmm.
You do this for all the binary operations. In the case of division, you have failure. So if the second operand is 0, so it's the same for equality and all of that. Then you have choice, and choice is where you actually use the skip computation. So essentially, this is the guard of the if statement, so of the if then else statement. you want to compute the result of the guard. If the result is 1, then you will execute the first branch. So the N branch, yeah, and you will skip the other one. Why do you want to skip the other one? Because of how these kind of stack computing works, you need to consume all of the tokens. Yes. And the only way to consume the tokens is by either executing them or skipping them. So if you did not have side effects, it would be fine to execute the branch you're going to ignore. But then again, if you have side effects like prints, you're going to print stuff that you're not supposed to print.
Like
so
print, load, and store as well.
Yes, also store and stuff like that, yeah.
Yeah, basically the issue is that you don't know in advance the number of instructions in a branch.
Because the thing is, usually you have 2 steps. You have a lexing and then you have a parsing. In this case, we only have a lexing and then you execute directly on the stacks. Mm-hmm. So it's kind of a weird way to do an interpreter. But
it's a just-in-time parsing.
Yeah, essentially, yeah. You do just-in-time parsing, yeah. And the mirror image of what I said happens for the else branch. And then what you return is either the result of the first or the second branch. Then the sequence, what the sequence does, it executes the first branch, ignores its result, and then executes the second branch. I mean, not branch, but the second sequend, I think. Mm-hmm. And then we have load and store that do what you expect. So load has a check for out of bound load, and it will read from the memory, whereas the store will write to the memory, and then print will print. And then you have the 2 more interesting things. So you have the repeat, which is essentially 4. You write 4, and then you write a certain number, and then you write an expression, and it's going to repeat that expression that number of times. Mm-hmm. So what you want to do is you want to compute how many times you want to do the repetition, and then you want to copy the body of the loop, and you want to execute a copy every time. The reason you want to have a copy each time is because if you don't have a copy, you will consume all the tokens and you won't have them anymore. So it's necessary that you go and copy it each time. And the same is true for the while, but in the case of the while, you also have to copy the condition, so the guard of the while, because at the end of every loop, you have to check whether the guard is true. Yes, then we have a couple of failures. Either you have reached the end of the stack, which happens when you write essentially syntax errors, and this is when an operation is not yet implemented. And yeah, this is Metaperk. Okay, so the goal of Metaperk is one day to be able to write Perk in Perk.
Yes, definitely.
Yeah. And at that point, it will not be an interpreter; it will be a compiler.
A full-fledged compiler, yes.
Yeah, but we will need some more stuff. So I think we will need, for example, some basic pattern matching.
Oh, no.
In order not to use tuples and stuff like that. Yeah. And the thing is, there's already a couple of people that want to contribute and do some stuff for us. If you feel like implementing pattern matching into Perk, please
definitely get in touch with us.
Yes, get in touch with us. Do a pull request. Yeah, we will definitely look at your pull request.
Yes, absolutely.
Yeah, this is an opportunity for you to contribute to a major open source project.
Major open source revolutionary language.
Major crypto revolutionary AI and
IoT
then some other
for health, quantum.
Okay, so that's it. Thank you for watching the video.
Thank you.
If you liked it, like and subscribe. Oh no, we have the.
Oh.